Hello, everybody. Thank you for joining today's webinar entitled Introduction to Consumer Packaging Testing. Before we start, I wanted to go over a few things. So this is a Mecmesin webinar. Mecmesin is part of the Physical Properties Testers Group, or PPT for short. The PPT group consists of various expert brands specializing in physical properties testing solutions, encompassing areas like tensile and compressive strength, torque testing, textile analysis, and real-world dynamics such as shock and vibration. The other companies within the PPT family are Lansmont, James Heal, and Aluris. If you want to know more about the group or individual brands, you can visit the PPT site and also explore the content and on-demand webinars our brands have available. I've already put a link in the chat box for you to review. So that's just a click away. But back to Mecmesin, we operate technology labs in Sterling, Virginia, and Slinfold in the United Kingdom to assist customers through education, proof of concept, and testing demos. If you have specific physical properties testing requirements, please contact us as we have a global team that is able to assist you. But let me introduce some people on today's call. Moses DeRocha is our presenter for today, and my name is Sharon Smorenberg. I'm one of the organizers. We also have various support staff throughout the United States, Europe, and Asia. So if you need information or support, we have somebody that can assist in your region. We do want to keep it interactive, so please feel free to ask questions. You can use the question box throughout the webinar to type in any questions you may have. We will then address these questions at the end of the webinar. The webinar again will be recorded, and you will receive the recording at the email you used to register with. So feel free to share it with colleagues who missed it or keep it on record for your own review if needed. And with that, I will turn it over to Moses.
Thank you, Sharon, and good morning, everybody, and thanks for making the time to join our session today. As Sharon already mentioned, we're going to be looking at an introduction to consumer packaging testing. Now, the different components of this presentation could essentially be a whole hour on each different test application, whether it's paper or plastics or torque. And so we're going to stay true to form here and stick to pretty much just the basics and an introduction and more essentials. And even though we'll try to cover as much ground as possible to explain all the different aspects of our capabilities. And as Sharon mentioned, if you all have any particular questions at the end of our presentation, definitely feel free to ask those questions or email us after the session, and we'll be able to assist in any way that we can. Okay, so real quick, we have a relatively short agenda, but it's a pretty beefy agenda as well because there's so many different encompassing topics here in these general points. So we'll start primarily. Now, what we try to do in a lot of these essentials or introduction is cover enough ground where all of our attendees at least take home something. For those who have been in the industry for a long time, you'll be able to refresh your memory on a few things. And for those who are just now a little curious about what this is all about, we'll still be able to get a refresher course on what this is all about. So we'll try to make sure everybody at least takes home something from this session. So we will touch briefly on the importance of packaging testing, and then we'll look at some of the industries where packaging testing is critical. And that's usually where sometimes, depending on where you are and what you do, these might trigger some certain familiarities on, hey, I know that, I recognize that, and so on. And then we'll delve into some of the actual applications. We'll look at the major applications in plastics. Now, as I mentioned right off the bat, there's so many different applications, but we'll look at the main ones that you usually find. If anything doesn't register, definitely feel free to reach out to us about your own unique testing application, and I'm more than confident we'll be able to assist you. So we'll look at applications in plastics, we'll look at certain major applications in paper, and also some torque testing applications in packaging. So first, why is product testing or packaging testing important? Sometimes you'll encounter a company that's been in business for 40 years and everything's become second nature. They know their product, they know the processes, and so why is it even worth it to test these products before they go to market? So you'll find four different stages or four different areas where product testing is important. First, during research and development. Obviously, as you research and develop your product, you want to know as much about the product as possible, its strengths, its viability, its weaknesses, at what point does the product fail, and all of these kind of build what that future quality characteristic is going to be for all subsequent quality testing when you determine where your ideal values are for the strength, whether the hardness, the elongation values, the stress, the strain, the top load value, whatever the unique concept is that you're looking for in your products, you'll do some testing during research and development to determine where those strengths and weaknesses are. And then once those have been determined in quality control, we're looking to establish what the product standards are, usually either by subscribing to a specific ASTM standard or ISO standard or a mil spec, and using those guides to enforce certain quality standards on what that product should be, what it should conform to. Once those policies, the quality policies are set for any given product, it now goes into production where they stick by those guidelines or adhere strictly to those guidelines and maintain that product quality and safety. There are also instances where even though you're not the exact producer and you actually have suppliers, suppliers provide you with services and goods, especially products, and they provide data as far as the product viability, strengths, weaknesses, certain values on product failure, and so on. And in the supplier audit, if you're looking to verify if those values are true to what the information that's been provided, that's another level where you would usually find yourself doing some product testing or packaging testing to make sure those products conform to any requirements or information that's been provided by the supplier. So these are all the different stages where you would encounter product or packaging testing. Now, we encounter packaging testing or packages in our entire life. Now, we're comfortable with one product A over product B because it does everything we need it to do. So, for example, if you grabbed your favorite beverage, you're confident it's not going to collapse on you as you try to uncap it, or when you ship your fragile product in a cardboard box, you know if it's stacked five high or six high, it's still going to make it there in one piece. Or that when you go grocery shopping and you're handed your plastic bag or paper bag, the goods will actually make it to your countertop at home and not be distributed across your entire path, either between the shop and the parking lot in your car or on the way to the home. So these are all the different things we encounter daily, and we're hoping that whoever the producers of all of these are, that they actually properly quality tested the product, and so we can rely on these products. So it goes from just being a convenient issue, as in, oh my God, the grocery bag broke. It's an inconvenience, it's an annoyance. And sometimes it gets to a more serious issue where it's a matter of safety. So if these containers are supposed to be child resistant, are they truly child resistant? Is it easy for grandparents to get into their prescribed medication, but then harder for the little one to actually get into it? And that's a critical part of package quality testing. So when your brand's reputation is on the line, failure is not an option, because any one of these issues happening could cascade into all kinds of different liabilities, which most companies want to avoid. So at every stage, whether it's at the R&D, at the quality, at production, or at the supplier verification, you want to make sure that your products do conform, and you can only determine that by actually testing the product. So you'll find package testing in several different industries. As I mentioned, it almost impacts on everyday life in so many different forms, whether it's the automotive, in aerospace, in the medical and pharmaceutical, in paper and plastics, in cosmetics, in food and beverage, in manufacturing, in electrical. You'll find packaging everywhere. And our hope is that the products that we receive in the packaging is properly tested to withstand not only meet standards. If we took food and beverage, for example, we want to make sure that our favorite beverage or bottle of wine is properly sealed to preserve the freshness, but also not too sealed where we can't hardly get into the product, right? So these are all the different aspects of packaging testing that you'll encounter in all the different industries. Right. So we'll look at some of the typical applications in plastics packaging testing. Now, as I mentioned, there are a slew of different applications, but we'll look at the major ones. And if you have any additional questions on some of the ones we did not cover, we'll be happy to answer those. Primarily in plastic and blow molding testing for PTFEs or PET, you'll find top load testing or burst testing. Now, essentially, top load testing is done to verify the integrity of containers, plastic containers, whether they're bottles or cans or buckets, whatever the case may be, all kinds of different containers. And essentially, this involves compressing the container either to the point of deformation or failure, or applying a specific force to it to see when it actually fails, or just compressing it to a known deflection and then measuring the actual force resistance. So those tests can be either destructive or non-destructive. So in a non-destructive test, that's when we'll say, when we put these bottles in a carton, 12 of them, a dozen in a carton, and we stack them six high with product, during the process of either filling or storage or transportation, is it going to survive the process? How many stacks can we have without the ones on the bottom actually buckling? So those are all some of the different reasons why you would be performing top load testing. And non-destructive, as I mentioned, is when you actually test the product to failure to actually determine the point of deformation or the point at which the product actually fails. Then you also encounter burst testing. So if you've seen your ketchup packets or your mayo packets or some cosmetics in the creams that are in pouches or anything that is sealed or welded at the edges, one, we want sealed for freshness, and we also want to know that if you accidentally sat on it, you wouldn't make a really bad mess. So those are all some of the different tests we do either for burst or for top load in the plastics industry. And then also there are peel and adhesion strength testing. Now you'll find this in packages that have foil seals and so on, where again, we want to make sure the product is sealed to the point where it preserves the freshness of the product and also easy enough to peel back to get into your favorite, cup of yogurt or fruit or whatever you have there. So peel and adhesion is a big part of it. There are also points where we do pressure sensitive tapes and packing tapes and so on to measure either in a 180-degree, 90-degree, or T-peel style testing to measure the weld strength, the peel strength, or the adhesive strength of the products. There are also instances where we do flip cap or pull testing on caps. Um, in your kitchen cabinet where you have all your spices, most of these spice bottles will have the flip cap. We don't want you to take a nail out just trying to flip the cap, right? So we want to make sure that the actual flip strength is properly tested and measured. So when it gets to the consumer, they can easily get into the product while still preserving the product quality. So what types of testers are usually used in plastics testing? So they're simple motorized force testers that are geared towards simple force applications, where top load, simple pull applications that do not require a lot of nuance in the test. It's pretty simple. Configure a simple test, run to a specific force, run to a displacement, run to failure, one or the other. just to measure the characteristics of any given sample in the plastics industry to make sure it actually meets your own test standards, whether it's an industry standard or your own internal standard. So you'll encounter simple motorized programmable testers that are the better method as opposed to, say, a handheld. There are handheld instruments that are often used in these industries, but there is a lot of operator error in these test methods because some of the important factors in any given test would be the factors of speed and displacement, and those are usually going to be guessed by an operator. So you want to establish an environment where those two important variables are established, where you can program the test speed, program to a specific displacement. That way you can then establish a more consistent testing environment. And then for the test applications, especially in the medical device and the pharmaceutical industry that are testing to specific ASTM or ISO standards, you obviously want to use software-driven testers, not just because of the sophistication or the nuances in the testing, but often if you're testing to specific standards, there are inbuilt calculations there on the type of data you're generating, and that can only be achieved using the actual software that allows you to calculate and generate things like elongation, stress, Young's modulus, yield, and so on. And these are all data that cannot be generated using either a handheld force gauge or a simple motorized tester. So these are the two methods that we usually would recommend in the plastics packaging industry for testing, whether it's destructive or non-destructive testing. Now, packaging testing in paper. So usually you'd encounter this is going to be a more, now, as I said, there are several different applications. We'll start with the ones that are most used, and the edge crush test is a huge one. If my marketing team will testify to this, we've had a flow of inquiries on edge crush testing in the last few months because, again, for the same reasons, even though the plastic bottles have been top load tested, what about the actual cartons that they're being transported in? What is the integrity of those cartons? You know, are they strong enough to withstand the storage and transportation before they actually get from factory floor to the consumer? So we'll do the actual wall of the cartons, and there is a Mullen test that actually tests the collapsibility of the actual cardboard. And there are several different ways of testing these in several different sizes, whether it's a single wall or a double wall or the reinforced and so on. But this is a really important part of some of the testing we do in paper. And then there was one that is not listed here, but I'd like to quickly touch on perforation testing. For those of us who are still, true to paper checks, when you get your checkbook, somebody has to test the perforation so you don't rip it in half just trying to tear it apart. Or your paper towel in your kitchen, if you're looking to tear just one piece, you don't end up either ripping it in half or tearing three pieces when you intended to. So the perforation in there, the perforation strength is another important test in paper testing. Not listed here, but it's also important. It's a critical part of paper testing. And then coefficient of friction. Now you'll find this in books, magazines, and so on, where we're making sure that in the course of production that the papers are not too coarse where they're rubbing off or not too smooth where they're sticking together. So the COF test is critical in all types of testing, as I said, whether in the publishing industry or the cosmetic industry or even the food production industry as well. And then there is the actual carton crush. So after testing the actual walls of the carton, now we'll do a complete crush of the entire carton, which essentially simulates what happens when you stack these cartons either in storage or during the process of transporting from factory floor to the consumer. That is a critical part of what we do in paper testing as well. And now all of these tests can either be destructive or non-destructive. So if you took carton crush, for example, if there is a set standard, either as an industry standard or an in-house that says a 10 by 10 by 10 box should withstand 200 pounds of top load, you can essentially run to that specific load to see if it actually withstands that or it meets that minimum threshold. If it buckles before it meets that minimum threshold, it was a bad sample to begin with. Then it's time to go back to the drawing board and find out what's happening with the walls. We might have to do some additional ECT testing and so on, but these are all critical in that entire packaging production process. The types of testers that are used in paper testing are going to be very similar to what we use in plastics as well. So again, you can use motorized testers, but there are limitations, especially since in paper testing, there's so many different testing standards, ASTM and ISO standards. Again, because this is more of an essentials, we're not going to list all of them here because as I mentioned, any given one of those, we could essentially just take top load testing on cartons as a topic and spend a whole hour go through all the different ASTM standards at a future date. But for now, I'll just briefly touch on those as we go through the different slides. So preferably, if you're testing to ASTM standard, then obviously because of the kinds of calculations that are warranted or required, you prefer software-driven force testers. Now, the limitations to force the software driven force testers are always going to be the size of the sample. So for example, you could get a single column software driven force tester, but if you have a carton that's 24 inches by 24 inches by 36 inches, for example, it would not fit on any one of those single column testers. And sometimes it might even be a challenge on some of the dual column testers. So besides the software driven tester, there are also dedicated testers that address the larger size containers or cardboard boxes. One example is our Squeezer Pro that is manufactured by our sister company, Lansmont, that accommodates samples up to 30 inches by 30 inches with a 48-inch travel vertical. And there are also additional options for even larger boxes by using extended or enlarged base plates. And this uses the same Vector Pro software, which gives you all the bells and whistles to allow you to control every aspect of the test, the speed of the test, whether you run into a specific force for 100% testing, whether you run into deflection, whether you run into point of deformation or failure, and you'll be able to gather all of the data that you need to essentially create a report or to analyze for any particular product that you're creating in that industry. So package testing in torque. Now this is a little different and I'll spend a little bit of time here. So we need to hydrate, guys. We need to take our medications, we need to hydrate, and we need to entertain ourselves. So whether it's a bottle of water or a bottle of electrolytes or your medication, prescription medication, or your favorite bottle of wine, whether it's bubbly wine or red or white, all of these products need to be properly tested before they get to you. And the key here is because there is a capper that's actually applying application torque to these containers, we want to make sure that once it gets to the consumer, that process preserves the freshness of the product and also allows the consumer to easily get into the product, right? So in the case of cap torque testing, this is also an area where it can be destructive or non-destructive. There is a direct correlation between the actual torque that's being applied at the capper on the line to whatever the release torque value is. So we have three types of tests that we do in cap torque testing. Either we're performing mostly actually a release torque where you just grab a handful or a dozen or whatever your batch size is of containers that have already been capped, put them on a given tester, and then run a release torque. What you try to simulate what a human would usually do once they grab one of these off the shelf, either in their favorite department store or whatever the case may be, for every grocery store or out of their refrigerator for that matter. And you run that entire batch and then compare the release torque values to what you expect to see. The higher the value, the more your brand suffers because people are starting to lose confidence in the product. Nobody wants to have to buy, something else online, a decapper essentially, just to be able to get into their favorite bottle of water, right, or favorite bottle of wine, whatever the case may be. So we want to make sure that whatever application torque the capper is putting out on the line, we'll see a corresponding release torque value that again preserves freshness of the product and the quality of the product, but also allows consumers to easily get into it without having to buy additional product just to uncap bottles. And then there is the application torque. So in those instances where based on the results you generate from your release torque testing, if you have numbers that are all over the place or values that are all over the place, usually the culprit might be the actual capper. That means the capper is not applying uniform torque. Because usually these cappers, whether they're pneumatic or hydraulic, are applying in uniform capping or application torque to these caps. Let's say it's between 10 and 12 inch-pounds of torque. When you grab a handful of samples and you put them in a tester and you run release torque, as long as that torque range is consistent, you'll also see release torque values that are consistent. If those numbers are inconsistent, another thing you can do is simulate what that capper is doing by applying actual application torque to your containers using a tester and then running release torque values to see if you see the type of results that you expected just in the beginning, right? So if those numbers are off, then you can confidently say the capper is not doing its job or it's applying uneven torque to your samples. So it's time to kind of revisit and see how that process can be corrected. That same process. And then obviously there are also the finals. Let me back up just a couple. I did mention three types of cap torque testing. The final is we use the term crossing the threads, right? Testing to destruction. How much torque do we need to apply before the sample just completely fails, where the cap just spins without actually tightening? So then there's essentially just a destructive test to see exactly what the ultimate maximum torque is before the sample is destroyed or it crosses the threads and just spins freely. So those are the types of torque testing applications that you would see in cap torque testing, whether it's release torque, which is primarily the test you would be doing, or application torque to simulate what the capper is doing on the line, or the actual destructive testing in that application. Right. And then there is an extra dimension to this, which is the push and turn or the pull and turn cap torque testing, which is for child resistant closure or the CRC. Now, this is usually to activate a mechanism that allows you to uncap for safety reasons, right? And you'll find this in chemicals like bleach and so on. And you'll find this in prescription medication, again, to prevent people that that particular product is not intended for getting into, especially children and minors. And again, so usually this involves applying a known axial force. What we usually do is apply a certified weight to simulate that push on force before you run that torque application to uncap, and then we measure both values. The reverse is true for bar tops or for wine, sparkling wine type corks, where it requires a twist or a pull and a turn, essentially all in one. And so in those instances, we actually use a rotary torque that's powered by a motor that simulates that turn as you pull the cork out of the bottle. So these are the different testing applications that you'll encounter in torque testing. The types of testers, once again, you could essentially, if you're a mom and pop operation running your family winery, not making much volume, you could essentially have a simple tabletop torque tester that will measure torque either in the clockwise or counterclockwise directions, which simulates application and release torque. But how fast are you turning that cap and how far are you going? If you go too far, you may be over torquing. If you don't go far enough, you may be under torquing. So to remove any of those uh, um, inconsistencies or errors in the test, we recommend at least a motorized tester that takes those two important values out. where you can set the speed of the test, run at 2 revolutions per minute, run at 5 revolutions per minute, run at 20 revolutions per minute. Again, the key here is trying to simulate what humans do if they grab the bottle of jam and they wanted to uncap it, and then run to a known angle. 40 degrees, 30 degrees, 360 degrees to keep it uniform. And then we'll measure whatever the torque resistance is. First, we'll get that initial torque that it takes to break the seal or the tamper evident bands, and then the running torque or the average torque that it takes to actually uncap the cap or the container lid from the container. So base setup would be a simple motorized system that measures release torque, but then you have the ability to program simple tests of running to a specific angle at a given speed, or running to a specific torque in an application test, or even running to destruction. But if there are additional nuances in the test or complexities in the test that require additional calculations, I'll throw one out there for lure lock testing for syringes. That's ISO 80369. Because it's a medical and pharmaceutical testing application, there is a standard governing it, and there's specific testing calculations for it. We would recommend the best method, which is a software driven tester. Why? Because the software gives you the ability to enter in those calculations and then run at the given speeds at the given times, run all the different nuances in the test, and the complexities in the test can be accommodated in a software torque driven tester. So between those two, you have just a regular a tester that's used for containers, plastics, bottles, cans, and so on. And then you have one that's more of a precision torque tester that has sensors that go really low to accommodate very precise, very low torque testing applications. But that would essentially be the two approaches. Again, you'll encounter the same types of tests here, whether it's a simple release torque, or whether it's an application torque, or it's a testing to destruction, or in the cases where you're testing to a specific standard, like the one I just previously preferenced, the lure lock testing. It has a specific requirement for applying a known torque. I believe it's 1.2 newton meters, and then doing a vacuum check to make sure there are no leaks in the syringes or the lure connectors. So this is critical in the medical device industry. And as we say, it's not just a matter of convenience, it's more of a matter of safety. All right. So having determined what the industry is, what the type of test is, and then having selected the type of tester for your testing application, the next big question is, how do you go about establishing a consistent and repeatable testing environment? Because the last thing you want is having spent the time, the money to put all of these together, and then still coming up with all kinds of results that do not meet your either your preset standard or whatever your industry standard is, if you're actually subscribing to a specific testing standard. So there's several different points. I use this as a checkbox that we usually give your quality managers or your manufacturing or production managers, and they check all of these off to make sure each of these are covered, and that goes a long way in helping you to establish a consistent and repeatable testing environment. So, first of those, first factor, defining the test objective. Why are you even testing the product? Right? So that usually, whether you're at the point of R&D, or at the point of QC, or at the point of production, the point of supplier verification, you need to know what the objective is. What are you looking for in the test? And that usually means you know what the product is. I'm going to take your 20-ounce bottle here, and we'll say, all right, so in our 20-ounce bottle, PET bottle, which holds water or your favorite beverage, we expect it to meet a minimum threshold of 30 pounds if we applied a top load to it. Or if we compressed it to a quarter of an inch in deflection, we should see a minimum of 20 pounds. If we see something higher, great, our bottle is strong enough. If we see something lower, there's a problem. That also tells us it might not survive the process of filling or storage or transportation and so on. So the test objective needs to be defined. That way we're not guessing, right? Back in the day, we would take the guy with the biggest forearms. They'll try to crush it and they go, yep, it's good. Fortunately, we don't have to do that. So if you have a tester, having the tester is just one step. Defining the testing objective is the next important step to establishing consistency and repeatability in your testing. Next step is to establish a testing standard or requirement. All right, so we know this particular sample needs to withstand 20 pounds or meet that minimum threshold of 20 pounds of force using that 20-ounce PET bottle. How do we go about testing that? How do we determine what the test speed is? Is there already an existing ASTM standard that establishes the different parameters for this test? Is there an ISO standard? Or are we developing our own in-house standard? Whatever the case may be, it needs to be established clearly so each operator understands exactly what they're doing. Now, ideally, if you're using software driven testers, all of that has already been programmed into it. So we'll say, here's the test for the 20-ounce bottle. All it's been programmed, the speed of the test, whether we compress into a known deflection, whether we're applying a specific force or we're testing to destruction, all that's been programmed. And then the kind of data we're looking for the maximum force, or we're looking for the maximum deflection, or we're looking for the point of deformation, we're looking for the average force. All that information is all configured in a test. And so all the operator essentially has to do is just put that bottle in and push a start button to start the test. But the testing standard, again, whether it's an ASTM standard or an ISO standard or an in-house standard, needs to be established so each operator understands exactly how to run that test. The next step is the appropriate testing equipment. So yes, we've already discussed, either handheld or portable devices or testing instruments. We've also discussed motorized testing systems that allow you to do simple force testing applications, and also software-driven testers that allow you to do the more sophisticated testing applications. That's also just the first step. The next part of it is that next part is, all right, if our carton is 30 by 30 by 36, then obviously we need to select a tester that's able to accommodate that large size carton on its testing in the testing area. Not just that, but also if we're expecting a maximum force of 800 pounds, we obviously need to select a tester, and it's a combination of load cells and fixtures that are capable of accommodating that maximum force, and sometimes a little more to accommodate any outliers you might have, or for any samples that might go over whatever your expected maximum force is. So all of that goes into the process. What's the type of sample? How much force are we expecting? That goes into the equipment selection process. And then the final step of that is, what types of fixtures are we using? So if you're in the blow molding and the PET industry, you want to say, okay, so we're testing empty bottles. So we want to use compression plates, but are they going to be vented compression plates, or are they going to be non-vented compression plates? So if we're using vented, that allows us to let all the air out of the empty bottle, so we're not building up pressure and spiking up whatever those top load values are. We'll let the beverage company that actually fills these plastic bottles with actual product use a non-vented compression plate to perform a top load test, that more simulates more of a real life process of storage or transportation, and however many you need to stack high. But grip and fixture selection is critical in the test as well. You select the proper equipment, you have your test procedures all set up, you know what your testing objective is, but you have the wrong fixtures. Guess what? You're going to get bad results. And it's as simple as that. So grip and fixture selection is also critical in the process. And the final step, I'll get to the final step here first, but the developing a standard operating procedure for operators and staff. Now, this usually comes in when you've checked off all of these boxes, but then the process of preparing the sample, this is something that the software cannot do or any machines cannot do. So we'll say, listen, we want to test in the testing environment where it's usually 72 degrees at all times. We need to make sure you're maintaining the 72-degree temperature in that testing area at all times. We want to make sure each sample is cut at a 1 inch wide by 6 inch lengths before we do this tensile testing for these plastic pieces. That has to be true for every single test, regardless of who the operator is. So sample preparation, the testing conditions, testing environment, testing temperatures, those are all important. And if we want to say, hey, operators, we need everyone to wear gloves so we're not transferring grease or any, smudgy fingers onto the product, because that might actually influence the types of tests we're doing. If you took, for example, coefficient of friction, if you dropped anything on there that created additional roughness, you might see values that might not necessarily be true to the product you're testing. So an SOP for operators on how to properly maintain certain standards for uh, um, preparing and testing samples is also critical in the process. So these are all the different factors, all the boxes that need to be checked off. And then finally, if all that's been done and you're still seeing inconsistencies or products are not repeatable, it's okay to check the actual product. This is usually a sore topic, and that's because you'll always get a little bit of pushback saying, "Listen, we've been doing this for 50 years. We know our product. It has to be the machine." Not always, right? It's okay to go back and take a look. In the process of testing caps, for example, if your release torque values, you're only getting a 20% pass rate and 80% of your samples are failing, it's more than likely because the actual capper is not applying uniform torque to the caps. So it's okay to go back by either by simulating what the capper is doing with a tester and then testing again. And then once you get your actual consistent results, you can then go back and check. And there are ways of checking. There are gold reference bottles out there that will allow you to measure the actual torque being applied and so on. So you can check what's happening with the product. All these products are coming out, they look great. But when you put them in and you test them, you're not seeing consistent results, and that usually is a reason to go back and take a look at the any product anomalies you might be finding. I'll give a quick anecdote here. We previously tested samples for mason jars that had legal moonshine here in there is a distillery in North Carolina that makes legal moonshine, and they reached out to us and said, listen, our end users, our consumers are finding it difficult to open these mason jars to get into their favorite, the product. So we found out in that final analysis that after production, the crystallization of the sugar in the beverage was actually creating higher than normal release torque values. So again, that's something you might not necessarily foresee unless you go back and take a look at the product. Because what they did was before they actually filled the mason jars with product, they would perform a closure and release torque, and all the values were great. But once the products were filled and they sat there for a day or two and they went to perform a quality spot checking, the values were much higher than they had seen on the empty jars. And apparently it was because of that sugar crystallization. So it's always okay to go back and look at the product just to see what's happening. And you might catch an anomaly or two that might contribute towards establishing that consistent and repeatable testing environment. Right. And that brings us to the end of our webinar today. And I will toss it back to my colleague Sharon for questions.
Thanks so much, Moses. If anybody has any questions, now is the time for you to type it into the question box if you have not already done so. And just a reminder to everybody that this is obviously, as Moses said, it's an introduction to consumer packaging testing webinar, and we are looking to do more in-depth ones. So please do get in touch with us if there is a specific topic you'd like us to cover. Obviously, you can just send that to either Moses or myself, moses.derosha@ppt.com. So yeah, please feel free to do this. I don't have a question. I just have a comment. So, or somebody said I would be happy to perform secondary testing on moonshine jars. I think you're
Me,
not
me
alone.
too. Me too, John. And again, if you reach out to me, I'll be happy to share that product with you. They're amazing. And to you, Nicole, as well. We'll send you a couple of gifts probably.
Oh gosh.
All right.
Okay. I don't see any questions really coming
Okay.
through.
Okay.
So If you do have any questions following the webinar that you'd like to follow up on, please send them for our attention to the email shown on the screen. And again, thank you for joining us today for this introductory webinar. And we really look forward to hosting you on another one. And like I said, please do let us know if there are particular topics that you are interested in us covering.
All right.
Thank you
Thanks,
so much.
everybody.
Have a good day.